how we work with big parts, and also I want to show all the improvement we do inside the HSR and HSM. First, I want to start with these parts. This is big parts. If I check the part, you can see the length is 1,653 millimeter. It's big parts, and if we look here, you can see a lot of surfaces, and it's very, very difficult before to work with this with the old version in SolidCAM. But now with SolidCAM 2013, we do a lot of improvement to work with this part. Okay, I want to start SolidCAM and to show today how fast, if I compare with old version, that means how fast we can work today, and really we can work with big parts. Okay, now we start the project. We create the CAM part. Okay, we see the part really is big. Now we start SolidCAM, and of course it takes few seconds, but it's, if we compare with the old version, it's really work more fast. Okay, now we have the part here, and I want to define the coordinate system, and here we do a lot of improvement. We do improvement to define the coordinate system. You can see I pick the faces. Okay, I can rotate, pick the coordinate system, and you can see really very fast if I compare with the old version. Now we finished to define the coordinate system. Also, if I go to the stock, pick the face, immediately we can see the box and the stock is ready. I continue with the target, and also pick the model, immediately I have the target, and we continue. Okay, we finished to define coordinate system, stock, and target, and now I'm ready to add a new operation. I want to show also the improvement we do. It's not only in the coordinate system and stock and target. Also, we do a lot of improvement to generate STL, also to work very fast with the simulation. And I want to add one operation, one HSM operation, to show also all this improvement. Okay, now I want to add HSM operation, and by the way, I want to show also very nice improvement we add inside the HSR and HSM. Generally, who need this improvement? All the resellers, the customer work with big parts. Most of the customer work with HSR, HSM, they need this improvement. Okay, I want to select the linear operation tool. I want to add a new tool. Okay, I work with big tool, 200. Okay, and I want to change to select also this color, and we finish with the tool. About boundary, okay, I want to define the boundary also. And passes. First, I want to do semi-finish, and you can see, okay, we show the first improvement. In SolidCAM 2013 SP2 hotfix 1. Now I work with SP3 DV, but we do the same change also in SP2 hotfix. I add here slider. Okay, why we add this slider? If you can look here, you can see here tolerance. We have this problem with new customer. Nobody will know, okay, I want to do part, but which tolerance I want to use? A lot of question here. SolidCAM add slider like the eye machining. Okay, here we have, I can work between 0.1, okay, and you can move, okay, and you can see each step, okay, we work with different tolerance. Of course, I can handle all this tolerance from the SolidCAM settings, and I want to show later. But now I can use the slider, okay, and also I can do check on okay, for this example, I want to work with 0.05 because I want to calculate fast, and my step over is 2 millimeter. This is about the tolerance. We do also the same in the point reduction. Also the same problem. Nobody know, and also a lot of customer start to do a lot. That means he go to the tolerance, put here 0.1, and after this he damage the part and start to ask why. But now with this change, no. SolidCAM, okay, suggests for you to work between this number. If you professional, if you know what you want to change, okay, of course you can go to the tolerance, open, and put what you wanted here. But SolidCAM all the time keep the work without do any problems when you generate the part. Okay, now I want to work with this, of course, B direction. Okay, now I want to do the calculate. First, we work very fast to generate STL. You can see if I compare with the old version, to generate STL now in SolidCAM is work more fast. And also after this I want to change the tolerance, and you can see also with 0.01 you can see how fast we can work today. Okay, now it's not only when we generate the STL, also when we run the simulation, okay, you can see now the simulation is work. Okay, I want to stop, go back to the tolerance, okay, work only with the default, okay, with 0.01. Now when I change the tolerance, I calculate the STL again, and here I want to work with 45 degrees, and I want to calculate again. You can see, okay, I generate STL again, but now it's work fast. Before with the old version it's take a few minutes, but now with SolidCAM 2013 it's work really very, very fast. And now you can see also the process here, and okay, I go to explain later how the SolidCAM HSM process manager working, and I want to explain all the steps. That's mean how is going inside this process, this manager. Okay, and now I can run, and you can see the simulation work fast, the calculation for the STL work fast. Really, the all in SolidCAM 2013 work more fast. You can see here only one part. Okay, I want to stop and show more big part, and of course I want to run also operation to see really how SolidCAM 2000. Eddie?
Ahmed, everything is okay.
Eddie?
You can continue.
Ah, okay. I see I have small problem in the communication, but okay, I continue. Now I want to open other part, also a huge part. Of course, this is customer part. We cannot give this part for anybody. You can see only in my computer. Very nice part. Also, if I go to the measure, okay, if I want to select it to check the part, you can see also 1,388. This is the, we can see here really very complex part, a lot of surfaces. And now, if I want to work with this part, really we have problem, yeah, and it's take a lot of time. But now you can see now how we can work with this part, how fast we can work also. Okay, now I want to run the part. Okay, of course, we see it's take time because really it's a huge part, a lot of surfaces, a lot of curves. But we can work also with this part very, very nice with SolidCAM 2013. Okay, the part is ready. I want to define coordinate system. Okay, I want to put the coordinate system in the center. Okay, we finish. and we continue to define the stock. The stock also ready. Target. The target also ready. And now we finished to define the CAM part and we're ready to add a new operation. Okay, now I want to show also for this part, I want to add HSM, I want to add linear tool, select, add also this tool, and now we're ready. I want to define boundary. Okay, I want to work inside, go to the point, and okay, the geometry is ready. Of course, I want to work in the center. My tolerance 0.05. My step over is 3. I want to start. That means, okay, of course, we can work to 45 degrees, B direction, and we can calculate. Now we generate STL. Of course, now the STL work more fast when we generate. And now we can see after this, we start to calculate the passes, the link. Of course, you can see now it's take more time, the first part, because we have here more surfaces and more curves, but generally it works very, very fast. Okay, you can see now the simulation is working more fast. You understand a lot of points here. You see very nice also tool pass, and also very, very fast. Okay, I want to stop here and to try to explain the first improvement we do inside the HSR and HSM. I want to open the operation and go to the passes. We talked before about the slider, and why we need this slider. You see the tolerance here 0.05. When I do check off, the slider is active, and now I can use the slider. You can see here the slider, and here we have default. Where we get this default, if I go back to SolidCAM settings, we add here tolerance, and the tolerance, you see all the tolerance for the prop, and here we have tolerance for HSM and HSR, and you can see I'm use HSM. This is my tolerance. I can change to 0.02. Here I want to add also 2. For me, I think 3 is better, and 4 here. And also I can put the default. That means when I start a new HSM operation, this is my default. That means if you put the default here, never you want to change the tolerance. Immediately you calculate. This is the nice change we do with this slider, and why we have the slider in SolidCAM. And if I do OK, and now I want to add HSM operation, and I can use the same tool, go to the slider. You can see now this is my default. I can move, you can see here all. That means if I start to move, you can see all the default here. I think it's very nice change. If you know, if I know I cut aluminum, I need this tolerance, I can select for aluminum, for steel, for any material here, and I think it can help for new customer. Also, we do the same also in the point reduction. Now also you see the picture, and I think now the all is clear. Also with the new picture, you can see what mean more fit arcs. Also, if you work without fit arcs, you want to know this is, we have here a lot of point. If I start to move, you can see, okay, we change, that means we don't have a lot of point, and this is the fit, that means this is the point reduction without the fit arcs. If I select the fit arcs, this is the situation. If I work without fit arc, this is the situation here. Okay, I hope this is clear. Okay, of course we write more information in the what's in you, and you know how, that means when we get this default and how the slider work with SolidCAM 2013 SP2 hotfix 1. Okay, this is about the slider. Okay, now I want to open other part, and really I want to show a huge improvement we do inside the HSR and HSM. I want to open this part. You can see the name is multi-core. Till today, that means with SolidCAM 2000 till to SolidCAM 2012, SolidCAM always work in the HSR and HSM with one core. If I open the task manager, like I see we have 4 cores here, and I want to show, okay, when I open the part and I want to calculate all the operation, what we do before, okay, we calculate operation one by one, and this part before, it's take 30 minutes. I calculate this part a lot. This is the time to calculate this part, but now with the multi-core, with all the improvement we do inside the HSR, HSM, it's take 3 minutes. Now, if I go to the calculate and I want to do calculate for all, first you can see the new process, and now if I open the task manager, you can see we have only rough. When I have rough, he don't go and take all the operation and start to do calculate. No, he calculate one by one. Also, we have here rough, and after rest rough. First, we finish to calculate the rest rough, and now when we go to the rest rough and all the other operation we have finished, you can see what we have here. That's when you can see we calculate the all. You can see the CPU work 100%. You can see all the core is working, and in this process all the time you can see, that means I calculate all the operation. You can see the status here. You can see first I calculate the passes, after this the link, after this we collect all the tool pass. In this dialog you can see what happened here. Now I send each operation for core, and you can see the CPU, it's work 96%, okay, and this is the reason before the calculation time take 30 minutes, now take 2.5 minutes. And really it's very big change, very important change. When you open old part with SolidCAM 2013, you can understand, okay, I think this is the one reason, okay, why we want to start to use the new version. And I'm sure with this version, okay, you can work more and more fast. Okay, you can see the multi-core working because we have more, we have 2 operations. When we have only 1 operation, you can see only 1 core work, and now you can see only 1, and you can see the CPU is working now only 20%. When we finish the all here, you can see immediately we calculate all the operation in the camper data. I think really is very, very important change. Now HSR, HSM, big parts work more fast in SolidCAM 2013. Okay, I think in few seconds, okay, we finish. Now I finish. Okay, now you can see we calculate the link, and now we start to do calculate for the tool pass. Also, it's work very fast now, and when we finish the all here, you can see all the operation is calculated. Well, you can see the all is ready, and if I look for the clock, 2.5 minutes, all the calculation before we wait 30 minutes to calculate this part. If I open if I open the operation and look for the tolerance, you can see the tolerance 0.002. I move 0.05. If I run simulation, you can see what I'm talking before. To calculate this tool pass for this part, it takes a lot of time. You can see now the tool pass, and with SolidCAM 2013 you can see how the HSM working now. Okay, I want to stop and to show when and how we can use this big advantage. Okay, now we talk about to open part from old version to new version. Okay, you calculate the all and you see the all is working very fast. Okay, how it happen when I start a new part? Okay, I want to close this part. I want to open the same part without operation and try to show, okay, how I can use this operation, how I can use this advantage and use the multi-core. Okay, I have the same part without any operation. Now I want to start to do the part. Okay, I want to suggest before I do a lot of the same this part, and I want to suggest, okay, how you can work today with HSR and HSM. Okay, I want to add HSR operation. Okay, I want to add to work with THM rough. This is my tool. This is my, I want to work with external 0, and you can see this is my boundary passes 0.3. My step down is 5. Okay, HM spiral. For me, it's okay. First, I want to do calculate. Why? Because when I use in the rough, first he do the rough, rest rough, and we see the multi-core work only when we have a lot of finish operation. Okay, now I want to do copy, change to rest rough, select other tool, the same boundary, and my step down is 2 millimeter, minimum offset 2 millimeter, and do calculate. Now I finish the rough and the rest rough, and now I want to start to add a new finish operation. Okay, you can see also now the rough, rest rough work very fast. Okay, now I want to move to HSM, and first I want to add linear operation tool, select this tool, the same boundary, I want to change to center. Okay, first I prefer, of course, to work with high tolerance 0.05. My step over is 2 millimeter, and I do calculate. Why? Because I want to see if I work in the correct place, if the tool pass is okay for me, and I run tool pass. Oh no, I want to work with different angle. Okay, I go now to the angle, change to 90 degrees. Okay, cam, I want to work with 0.05. Okay, change here to 0.1. 0.1. Okay, my step over 0.3, and I do now only save. Okay, and continue. Now I want to add rest machining tool. My new tool is 4. The same boundary. My reference tool is 7. Passes. The same wall, and now I go to the tolerance to 0.05. My step over is 1 millimeter, and I do calculate because I want to see the tool pass if the all is okay. You can see I can calculate fast. Of course, I can work more 1 millimeter. Because Why I work like this? Sometimes, okay, you start to see, oh, I want to calculate here, I want to work here. Oh, the toolpath, no. If you work with the correct tolerance and correct step down, step over, sometimes it takes 10 minutes. After 10 minutes, wow, I need to calculate again. But when I work with low tolerance, big step down and step over, now I can change to this, change the step down to 0.02, okay, do save, okay, go outside. I can take now this operation and do calculate, okay. Now if I open the process, you can see, okay, the multi-core is working, the operation is working, and I can calculate 4, 5, 10 operation, okay, and in the same time when I calculate only one. That means what I suggest, the idea is, okay, work with not with high tolerance, big step down, step over, do calculate, see the toolpath. If the all is okay, change the tolerance, step down, step over, and only do save. After this, when you have 5, 6, 10 operation, okay, do calculate for the all, and you can see how fast the HSR, HSM work today. Okay, this is about the multi-core, about the process manager we add to HSR, HSM. Okay, now I want to continue to show the new HSR operation. Okay, I have this simple part. In this part, I want to show the new HM rough operation. This operation we have in the HSR. Of course, we close this operation in SP2, okay? And I show this operation because we open again in SP3, okay? And I want to show, okay, SP3, I talk about September 12. This operation is ready in HSR and you can using, and this is the reason I want to show in this webinar. Okay, you can see the HM roughing here, tool. I want to select this tool. And now I want first to cut this pocket. Okay, 0.2. My step down is 5. And this is the new. This is the same all the HSR operation, but here we have 3 options. Step over type. We have core, okay, like to work in this area. We have cavity, like this pocket, and we have also HM spiral. Okay, I want to show all this option in all this area, and I want to start with cavity. Okay, and you can see in HSR we don't have a slider in the tolerance. Why? Because we have formula here. If I change to 0.5, you can see also this change 0.2 we don't have because we calculate the tolerance with formula. We have only the slider for the point reduction. And now, okay, I want to do the calculate to see how the toolpath is look inside with the HM roughing with the option cavity. It's work like pocket. Okay, and you can see now I can change. You can see we start from, okay. Also, I go, now we add here also like the pocket, percent from the tool diameter. I want to change to 60%, okay. Calculate again, now I change the default also to 65. And I want to run the, you can see it's work like pocket. Very nice toolpath without a lot of jumping all the time, okay. We work inside the pocket. Of course, this can work more fast, and okay, we finish the pocket. This option is very good for closed area, and this is the reason I use cavity. Okay, I want to continue now. The same tool, the same, but in the boundary, I want to cut the part here, yeah, in this area. And close. And now I want to change to first cavity. Okay, I want to see also when we have open area what happened. Okay, I continue with cavity. Okay, of course never we can damage the part. Okay, but maybe you cannot like the tool pass. Okay, you can see we start from inside to outside. You see the tool go outside. Okay, you can work, but of course you prefer to start from outside. Okay, we can stop. Okay, change to HM spiral. Okay, I changed to HM spiral. HM spiral automatically, if he see the part is open from this side, he start from outside. You can see now the tool start from here. Okay, and you can see he start from outside, work like this, yeah. And if I continue now, you can see always we start the cutting from outside inside like open pocket. I like this tool pass, but if I put now the tool pass like this, you know, maybe, okay, yes. And now I want to open the tool pass like this. Okay, you see here we have these stairs. If I go back to the operation and change to 15 millimeter, what happened now? I want to show the problem we have in the contour roughing and how the tool pass working today. Okay, I see I have 1, 2, 3 tool pass. What happened here? Nothing. But today, with this option, constant and flat, if I calculate again, I add extra tool pass only to cut this area. Now, when we finish, you can see 1, 2, 3, and 4. That means if we start to look, you can see here the tool pass, it's working only in this area. If I change, and you can see the tool pass working here, not in all the part, only in these surfaces. This is the big change we have here, okay? And I think it's worked very, very nice. And you can see also from this and from this side, okay, how this option is working. That means you can see constant and flat. It's very important option, and we have today here, okay? Now I want to continue, okay, and to show, okay, how the core work when I want to cut this area. Okay, we do save and copy, constraint, new, and this is my boundary. First, I want to work with constant, and I want to use HM spiral, okay? Maybe one step over, it's okay, yeah? Because I want to see, okay, how is going here. If I run the simulation now, okay, I stop. Okay, I change to 10 millimeter. Of course, with 100, we cannot do this. Simulation. Okay, now you can see how the HSM is working. You start from outside to inside, first with the corner, and after this, okay, you can see it's work like a spiral, okay? I think generally it's look nice, but if I go to core and calculate again, I think we can see better tool pass. What I want to say, okay, in this rough operation, you have a lot of option, okay? And you want to know, okay, what you want to use. You can see what we have here. You start from outside to inside because I start with core, But generally, okay, you see the jumps here. Okay, I think the HM spiral also is okay, and the core also work very, very nice. Okay, this is the HM operation, and I think it's work. If I compare with the contour, the old contour roughing, of course, is work more fast. We have a lot of option here. I think also the option constant and flat, very, very important option. Okay, this is about the operation we have here. Now I want to show now all the other improvement we add inside the HSR HSM, and I want to open the last part. Okay, we have this part. Okay, I want to delete this operation and start. I want to add HSM, and you know we have the horizontal machine tool, select, and I want to use this tool. Maybe I want to select other tool, 10 millimeter boundary. Okay, I want to go to silhouette, and okay, you can see this is my boundary. I want to do this area. First passes. My minimum offset is 4. Okay. Now I want to show okay how the horizontal working like today without the new change we do here. Okay, we finish, and you can see they start from inside to outside and cutting the surfaces. Okay, nobody like this. Okay, in some case, okay, you don't have any option. If the all is closed, okay, you must start from inside. But if you have the ability to start from outside, okay, now we have a new option like all the HSM operation detect core area. Now we can start from outside to inside. A lot of resellers, customers ask about this option, and now with SolidCAM 2013 we have. Okay, if I run the part, okay, step by step, you can see we start from outside to inside now, and it's worked really very nice, and we have this option. Okay, I want to continue, and I want to run now linear operation tool, select, and now I want to add new tool, and also I want to cut, that means I want to cut this area. Okay, this is my surfaces. Okay, we continue, passes, and okay, I want to use this tolerance. My step over is 1 millimeter, and B direction, calculate. Okay, I run simulation. You can see I do this, but now I want to know, okay, if I start now, sorry, and okay, I want to know, okay, if I want to add holder, that means what the length for the tool outside the holder. Okay, we have this option before, but now if I open the tool, you can see we have the option here. If I do now calculate minimum tool length, okay, I can do calculate, okay, it's working, but you don't see nothing here. Why? This option work only if you use holder. You can see we don't have nothing here. But if I go back to the holder and use holder now, okay, that means I use holder, select, you can see now I have holder, and if I calculate again now, you can see calculate minimum tool length, you can see now in the process, and after this you can see the minimum tool length, okay, should to be 46 millimeter. It's very important option if you work with big parts and you want to know, okay, what the minimum tool length. Now, before we put inside the miss parameter, but now we move to here. Okay. Now, I want to show also very nice change we do here. I want to add HSM operation. I want to select this tool. You see, I start with linear. This is my boundary, and I put here 0.05, and this is my tolerance, my step over 0.7. Oh, linear, it's not okay. I want to change now to radial. I change to radial. If I go back to passes, we keep the old, we don't delete like the old version. That means we save all this parameter. We save the parameter when we don't, when we have formula. That means step over, floor, the tolerance, the all. In this dialog, okay, we don't, that means we keep all this value, okay, and you can use, okay, also if you change from one technology to other technology. Also, this is very nice change we do. And now, if I go to the PowerPoint we have here, I can also show very nice change also we add inside the HSR HSM. Okay, first I show about, this is also very important, okay, this is the reason, okay, I want to show, okay, inside the PowerPoint. In SolidCAM 2013, okay, you can see, okay, here what we have. You see the colors, okay, and we use tolerance 0.01 in SolidCAM 2011, 12, also 13, and we do very good check here, and we want to check, okay, where is the best result we have, okay, and with SolidCAM 2013, okay, when I use 0.01 and 0.002, we get the best result. That means today, if you want to do smooth surfaces, that means the better surfaces quality, okay, we can give this only with SolidCAM 2013. Of course, SolidCAM 2013, this is a new MS library, and we see and we check, yeah, today we can give the best result. And in this diagram, you can see, okay, all SolidCAM 2011, 12, and 13, and you can see really what happened now in SolidCAM 2013. Okay, we talk about faster calculation. We talk about the multi-core calculation, and we can see in the new process. We talk about keep the parameter value after change technology, and you see this. I show also the hybrid machining, HM roughing inside the HSR. I show also how the minimum tool length is working. I show in the horizontal machining the new option detect core area. Also, we add symbol ordering. You know the symbol ordering. Now we have the symbol ordering in the rest machining. And okay, this is all the change. If we look, okay, what we do inside SolidCAM 2013 with the big parts HSR, HSM, I think it's really a huge change, a huge improvement. And I think also I feel today, I think the HSR, HSM really the best solution. And we want to think all the time. Of course, I know the MS library we have inside a lot of software, but I'm sure nobody can work like SolidCAM inside, also inside the HSM. First, we have the best user interface. We have now picture for each parameter. You can see this slider. We help the user, okay, to don't do mistake. We talk about the new customer. Okay, we have that means every version we think for the customer. Okay, we think that for the customer, when we add and change many thousand picture here, we think also when we add the slider. All the time, SolidCAM work with customers, work with the resellers, ask, okay, what we can improve and help. And this is the reason every version we do a lot of improvement, and all the time we try to do and hear the customer, hear the problems from all, and to do this change inside SolidCAM. Not only inside the HSR and HSM, I talk about all the SolidCAM module. Okay, I think, okay, I'm finished. And now I'm ready to answer about question, okay? Okay, the first. Okay, about this question, of course, that means, you know, we work with MS. To work with MS can do this connection only with STL file, and of course is more fast.
Ahmad, can you please read the question, because the attendees don't see the questions. Please read the question so they will understand.
How fast?
Thank you.
Okay, the question, I asked the question again. Okay, how fast is SolidCAM 2013 at generating intermediate stock model for rest machining? Is it best to use STL or FST file? Of course, what I want to say, okay, inside SolidCAM, that means if I go to, I want to add HSR operation. I want to go to contour roughing tool. Okay, select tool. In the passes today, you see we have the two options. Okay, I think STL it's more popular, and I think SolidCAM work okay more fast with STL, but we can work okay. That's mean, and we can use stock by FST file and also STL file. Generally, I see a lot of customer, a lot of resellers use STL file, okay? But if you have FST file, of course we can using and we can do rest rough. Okay. About how can I generate the files for VeriCut? Okay, no problem. If I close here, you can see we have here the option simulate. That means if you have VeriCut, you can see simulate. That means external simulation. And if I go to SolidCAM settings, you can see in the simulation. That means if I go to the G-code simulator, okay, you can see here we have option to work with DMG, GNAVI, IMS Verify, NCView, and also VeriCut. If you have VeriCut in your computer, when you do right-click in G-code, you can see G-code simulation, and okay, you immediately we take all the toolpaths, the G-code, and open VeriCut, and you can run VeriCut. It's work, and I see customer using. Okay, I think I see here we have only two questions, Eddie. If we have more, okay, you can ask.
Okay, guys, so this is the last chance. In any case, thank you very much for attending this webinar. Thank you very much, Ahmad, for such interesting webinar. For our attendees, I would like to say that you always can go to our website, solidcam.com. There you can find the schedule for the next webinars. Of course, as usual, next week it will be the next webinar in series of SolidCAM What's New webinars. In addition, you can find a lot of success stories about amazing iMachining technology, about all the innovations in SolidCAM latest 2013 version. In addition, you can find there trial version integrated to both CAD products, SolidWorks and Autodesk Inventor. So please use this tool, go to our website. And now I would like again to thanks to all of you. Thank you very much, and we'll see you next week. Bye-bye.
Thank you for all. Bye.
For your